Okay, so 4.3 is all about box plots. So we're going to really look at how do you graph them, what do you need to know about them. So that's all of today. So you basically know everything you need to know about a box plot. We're just going to put it all together. So the 5-number summary of a data set is the min, Q1, the median, Q3, and the max. This is what we're going to need for our box plots. So sometimes instead of like saying, give me all 5 of these, it'll just say, tell me the 5-number summary. So what we do is we take those numbers, we create a box plot. So a box plot is the graphical display that uses the 5-number summary to picture a distribution. So the length of the box is the IQR. So remember, that's Q3 minus Q1. The length of the entire plot, again, is the range. It's the max minus the min. Now, you may have heard these as box and whisker plots. You're in AP statistics, we just call them box plots now. So if a distribution has outliers, they're usually marked separately. So what we actually use, we call this a modified box plot. Okay, so here's sort of what a box plot looks like. So you usually have your min, and then this is Q1, then your median, then Q3, and then your max. So each one of these represents 25% of your data set. So remember, your median separates the middle 50, so the higher and the lower, and then the Q1 is the median of the lower half, Q3 is the median of the upper half. So if this is like super stretched out, that means that you're skewed. If it looks approximately symmetric, you're okay. If they're super close together, kind of that's where your cluster is. Now, if there's an outlier, what we do is, let's say there's an outlier in the upper direction. We'll put like a star. That'll be your max. And then this becomes, your highest non-outlier. Okay, if it was in the lower direction, you'd have a star here, and this would be your next highest non-outlier. Okay, so you can see where so we use a modified box plot. Now, how do you determine if they're outliers? So before we would just say it's something that is either greater than or less than everything else. There's actually something called Tukey's rule. And I think the new AP exam calls it the 1.5 IQR rule. So what that says, an outlier is anything less than Q1 minus 1.5 times the IQR, or anything greater than Q3 plus 1.5 times the IQR. So you need to memorize this. It's not on your formula sheet. The biggest mistake people will make is instead of using Q1, Q3, they'll use the median. So that, if you have anything less than or greater than, those are like your boundary points, and then anything less than or greater than, those are your outliers. So what we're going to do is we're going to take all the male weights that we had from the past couple notes, so this one, and we're going to draw a box plot. Okay? So, first thing we want to do is we want to figure out from the male weights, I'm going to do it up here so we have more room. We want to figure out if there are any outliers. So it's anything less than. Now what we found yesterday was Q1 was 128. So it's 128 minus 1.5 times 34. Anything greater than 162 plus 1.5 times 34. So, luckily we already had that done from yesterday. Anything less than 77 and anything greater than 213. So if I look at my data set, anything less than 77, I'm good. Greater than 213. I do have an outlier at 225. So what I'm going to do is I'm going to put a dot at 225, and my whisker is going to end at 195. So, draw yourself a big old line. Again, we want a title. So this is pounds. I'm going to start off at 90 and go up by tens. Oops. 210, 220, 230. I went up by 20 at the end there. Okay. So, 5-number summary. So you start with the min. The min is the lowest number. It's 97. Now, I'm writing the numbers in just so you can see them. You do not have to, especially if they're given. Q1, we said, was 128. The median was 142.5. Q3 is 162. And again, because we have our outlier here at 225, I'm going to go to my highest non-outlier, which was 195. And stop my whisker. Okay, so there's your box plot. It sort of looks approximately symmetric, right? Except for my one outlier. The center again was 142. In this spread, you could say the outlier is 34. The IQR is 34. You wouldn't want to use for box plots mean or standard deviation, because you don't know the mean, you don't know the standard deviation. So, box plots are nice because we can quickly identify the center, again with the median, and the spread, so either the range and the IQR. We can also identify symmetry or skewness, but not how many modes the distribution has. Box plots are especially useful for comparing distributions. Just make sure they're all on the same scale. So again with the shapes. So if you are skewed right, okay, remember that you had a lot of to the left, and then it's, so what should happen is your box plot should be sort of smushed together and then start to spread out. So that would be your skewed right. Skewed left would be the opposite. You're sort of spread out at the beginning and then close together at the end. Again, that's like extreme. Approximately symmetric. Again, everything should look symmetric. So it's about symmetric. The book will use the term mild outlier and extreme outliers. We just call them all outliers. Ignore the book. And again, we talk about modified box plots. So how do you do a box plot in your calculator? So sometimes it's like kind of annoying to do it all by hand, especially if you're running out of time. So what you do, I'm going to show you with that male weights data, because I already have it in my calculator in list 1. So you can just follow along. If you want to follow this, you can. So what you do is you go to second stat plot, and you want to turn your plot on. So I'm going to turn it on. You want the modified one. So you want number 4 here. I'm going to do list 1, because that's where all my data is. So you go to second, y equals, turn your plot on, go to number 4. Now if you have a fancy calculator, you can pick your color. Now if you go to graph, it's going to graph whatever you already have in there. I don't think I have anything in here. So if you go to zoom 9, zoom 9 is zoom stat. So it'll go right to your box plot. So then there's my box plot. And then this is my outlier at that 225. Now, if you want to figure out the numbers, you just hit the trace button. So there's my min, or Q1, median, Q3. And then this is, the reason they don't give it a thing is because it's the largest non-outlier and then your max. So sometimes it's helpful to do it just this way. Like I said, once we get into second semester, you're going to do box plot as one part of many things. So it's faster just do it in the calculator. Okay, and then what happens if we don't have a box plot? We're going to look at the mean and the standard deviation. So here's a bunch of data values. Let's go ahead and plot them. So I'm going to start 70, 80, 90, 100, 110, 120, 130, 140. So I'm going to put a dot. I'm going to plot all these. Okay, so what we're going to do, we're going to look at the percentage within each standard deviation. So I went ahead and I put these in my calculator just to save time. I'm going to tell you that, oh, I forgot 131 and 136. The mean is 107.1 and our standard deviation is 16.38. Okay, I just put these all in the calculator and hit one variable stats. So let's find the percentage within one standard deviation. So I'm going to do 107.1 plus or minus 16.38. So I get 90.72 to 123.48. So if I look down on my dot plot, from 90 to 123, I have 15 out of my 20. So, draw an arrow. 75% of my data here is within one standard deviation. If I go plus or minus 2 standard deviations, I'm going from 74.34 to 139.86. 74. I have 19 out of 20, so 95% of all my data values. If I go within 3, I have 57.96 to 156.24. That gives me 100% of my data values. So we're really going to talk more about this tomorrow, but really what should happen is most of your data should be within 3 standard deviations of the mean. Okay, so if you have standard deviation and mean, most of your data should be within 3. Not really a outlier rule like Tukey's rule, but kind of helps.